Hello. Okay, I'm going to explain about cottage water systems in Scandinavian areas. So here we have the pipe that goes underneath the frost level to the lake or river or well or whatever you have. So this one goes to the place where you have the water. Then you have electricity, and then you have the pipe that goes to the buildings where you want the water. And here we will put now the pump. It's not that easy. Electricity, that won't be needed too soon because there are things to do before that. This wouldn't be even, this wouldn't be a problem if you would do this just once and then it would work. But the thing is that we are in Scandinavia, so everything will get broken if it gets frozen. There's even a song, frozen. So if it gets frozen, it will get broken. So that's why I have to take this off and on and off, unless it's in a heated place. So that's why things get a bit complicated, because these things are not meant to be so that you take it off on and off. It's not that good. So this is the part that goes to the lake. So this is where it takes the water. And if this leaks air, nothing will work. The good thing about this pump system is that if you are at the cottage with wife and kids, so there's no end to it how many times you can say that you are fixing the pump and maybe drinking beer at the same time, because this takes ages and there's no way that the wife would know whether you are doing anything useful or you are just playing with the pump to have some quality time of your own. Okay, so this is our foundation. I already know that this will leak, but let's try to get it working first, so then we see where it's leaking. So this pipe, water comes from the lake. Here, this pipe, water is going away from the pump. Here you will have pressure. This funny thing here is to help to get the air out of this pump, because here is the space where you have the turbine, and this should be full of water, and if it's full, if there's air, it won't work. So here we have a special system. This system will help to get water inside of the pump, because you have to get the water inside of the whole system. The pump has to be full of water, and also the inlet pipe. So I don't know, 10-20 liters of water you have to get inside of this system before it can work. So here we have the inlet pipe that goes to the lake and to the pump, and there's a valve in here. You have to keep the valve open somehow so that you can pour water into the system, otherwise the air will prevent it from happening. So I'm going to stick a screw in here to keep it open for now. Okay, so I'm trying to fill now the inlet pipe and the pump with water. Let's see. going too well. There has to be something wrong. So what was wrong? That here we have the valve of the lowest point of the system. So that was actually open. But now we know that it's open. So now I can close this. And you should actually have this kind of valve that is in the lowest point of the system if you want to be sure that you can empty the whole water system before winter. We are pouring in more water. We have now, I think we have some like. The bad thing is that if you really are in a hurry that you would really need it to work, like your friends are coming to the cottage and you want water for them, this is not actually that fast. It's not that easy. And this is all due to the winter. Because of course in a warmer country you just do this once, but here we have to do this every spring. So even 30-40 times in your lifetime. Makes you wonder whether it could be an easier system. 20 liters so far. And we have some new system. I think now the thing is that the faucet in the sauna is open. Okay, now I closed the faucet in the sauna. And now the interesting thing is whether the water is coming away from the inlet pipe. So I'll go and have a look. Okay, now the water level is stable, so it's not going down. I don't know how that's possible because now it should be coming out from the inlet pipe, but it's not. So this is a typical cottage situation. I don't know what's happening. I think I have to eat at this point and try to figure out what's happening, because now it should come from. Even I don't understand how it all works. There seems to be a one-way valve in the pump, and that would be actually quite understandable because of course there has to be, otherwise the inlet pipe valve should keep the whole four bars of pressure. So yes, there is an one-way valve in the pump that keeps the 4 bars inside of the system so it doesn't go back to the lake. There's a valve inside of this pump that prevents the water going backwards from the high pressure to the low pressure to the lake. I don't know, but maybe there's, if you manage to get all the water away from the pump in the autumn and you leave it to get frozen, this will get broken. This is the pressure level meter, and this is the one that is adjusting the pressure level. So these will get broken because there will be tiny amount of water in there. So that you have this kind of thing you can open to air the turbine cavity. So interesting things happen if I open this. Now the water starts to pour. It's sucking air from here. So the water is now going to some direction, most likely the correct direction. So now the water cavity is full of water. Air is coming away from it. It's taking more water in. I think I didn't quite understand how this works. So it seems that there's actually a takaisku-venttiili in the pump, so the only way to fill this with water is to do it in the lake. So let's try that. Okay, this seems to be the only way to fill the inlet pipe with water, to do it in the lake, because I think there is a valve in the pump that I didn't understand is there. I think now it's full of water. Okay, I have even more stuff. So this inlet pipe, you want to keep it underneath the water but not in the bottom one. So I have this Jukola7 Koho that will keep the inlet pipe at the correct height. So there's inside of this, there's water, and this will float so that this will always be something like this, the inlet pipe. So that will help to keep the inlet at the desired level. It's quite easy to use. You just put it there and then throw it in the lake. And I have even this. This is the filter. Dragonfly. Now it's almost ready to put it into the lake. Into the lake. Okay, now we know that the suction pipe is in the lake in the correct depth. So let's continue and try to air this. So as you see, we have valve here. Something happened. Still water going in. So now I have put maybe some 40 or 30 liters water into the system. Now there starts to be some chance that it might actually work, the pump. Nicer sound. Of course, the thing you want to do something with is behind this other thing. It's only normal. Otherwise this would be easy. I mean, it could be anywhere, but it's directly underneath this other thing. So that's annoying. The water. Okay. I mean, eventually it's mystery. Nobody knows how these things actually work. There are many pipes and funny things happen, so I don't think even Jesus would know. The sound is changing. Okay, it's starting. We have almost 1.1 bars. No, 0.3. We have liftoff. We are very close to great success. Yeah, exactly. Now it is working. Pump works so that in here we have a valve. Here we want to put air pressure, maybe 2 or 3 bars, because inside of this there's actually a rubber thing. On the other side you have the water, and on the other side you have the air. That's because otherwise every time you use the water this would start, but because of there's this reservoir of compressed air and water, this doesn't have to run all the time. And you know that you have the wrong pressure here if the pump starts to work every time you open the faucet. So now we are getting some air here. So putting in some pressure, I didn't find my good pump, so I don't know the pressure level. That's actually a bit of a problem, because you should know the level of pressure. So putting in some pressure, I didn't find my beat this a couple of times, that you put the pump on and then you open this, some air is coming out, then you put the pump on. now it's test water, that's a good sign. Try not to get electric shocks. Now we have a stable pressure here, 3.5, and no, that's nice.